Hello. Alright, so the purpose of this video is to show you basically how imaginary numbers work. Okay, so imaginary numbers are the square roots of negative numbers. Okay, and one way that we can represent negative square roots, we can use this following rule that you see in green here. So this rule here, so basically I stands for imaginary number, and that basically equals the square root of negative 1. Okay, so we're going to use this in some shape or form in the examples that I present you. Okay, all right, so let's go into some of the examples. All right, so let's say I give you something like the square root of negative 4. Okay, square root of negative 4 is the same thing as the square root of negative 1 times the square root of 4. Okay, so if you guys kind of remember what I said earlier, I is equal to the square root of negative 1. That's the main idea behind this lesson. Okay, so what I see here is, well, square root of negative 1 can be replaced with an I. If you guys remember what the square root of 4 is, the square root of 4 is 2. So this is just I times 2. Now, when you're writing this out, usually mathematicians will usually put the I in front of the 2, or yeah, on the right side of the 2, so, or in front of the constant. So your answer would be 2I. 2I. So it looks just like that. Let's try a different one. Square root of negative 6. Okay, so when you get something like this, break it up the same way. So this is the square root of negative 1 times the square root of 6. Okay, what I see here, square root of negative 1 is I. Okay, and we're multiplying that by the square root of 6. Okay, so in other words, what we have is this is just I times the square root of 6. That's it. Looks something like that. Okay. Now let's say I give you another example. Since I give you the square root of negative 8. So if I were to break this up, this is basically the square root of negative 1 times the square root of 8. So same idea. What you want to do is you want to break up that square root of negative 1, and that's going to be I. So we have I times the square root of 8. Now what we need to do is we need to break up the square root of 8. Okay, so if you guys remember how to do that, 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. So what we have is the square root of 8 is the same thing as the square root of 2 times 2 times 2. Okay, and basically if you guys remember how to manipulate this, we have our partners in crime here. One gets shot, one comes out, and this becomes 2 times the square root of 2. So the square root of 8 is the same thing as 2 times square root of 2. So we're going to replace square root of 8 with 2 times the square root of 2. So we have I times 2 times the square root of 2. Okay, next what I see here is if you want to just put this in order, just like how we did for this example, this is the same thing as 2 times I times the square root of 2. Okay, so that's how you would break that up. Okay, so that's how these problems work. Okay, so let's say I put this more into practice. Okay, so let's start with something that you may be familiar with, right? So if we had x squared equals 1, right? So what we could do is, in order to get rid of this square, we can take a square root in order to get rid of the square. So square root cancels with the square, and we had x equals, the square root of 1 is going to be both positive and negative 1. So if you guys remember, we have x equals negative 1 or x equals positive 1. In other words, we have two possible solutions, right? So we have two solutions. If I gave you something like this, let's say I gave you like x squared equals 0. If I take the square root of both sides here, square root cancel with the square, and we get x equals the square root of 0 is just 0. In this case, here, you would have one solution. Okay, one solution. Okay, now let's take another case. So let's say I gave you like x squared equals the square root of, x squared equals negative 1. Okay, so let's say if I give you something like this and I take the square root of both sides. So we're going to take the square root of both sides here, square root cancel with the square, and we get x equals the square root of negative 1. Okay, so something interesting happens here. So again, like you guys may have remembered, so you can't have a negative square root. So this implies here we would have no real solutions. We would have no real solutions. If, however, we were to solve something like this, if I bring this all the way down, it would look something like this. So x equals the square root of negative 1. If you guys remember, when we take square root to something, we want to both consider positive and negative solutions. So this is going to be x equals, so if you guys remember, right, so I equals the square root of negative 1, right? So what we have is we can change this. This is an I and have a plus minus. So this would mean like x equals negative I or x equals positive I. So what we have, so no real solutions here, is the same thing as having two imaginary solutions. So yeah, so these two basically are the same thing, if you're wondering. Okay, but anyway, let's try to do another example. Okay, so let's say I give you a problem that looks like this. So let's say we want to solve for x. Okay, solve for x. I give you something like x squared plus 36 equals 0. Okay, so what I see is we can subtract 36 both sides. By doing so, this cancels. We get x squared equals negative 36. Okay, so next what I see is in order to get rid of the square here, we can take the square root. So we take the square root of both sides. Okay, so the square root cancels with the square. We get x equals, and we get the square root of negative 36. So just like the little pattern that I showed you earlier, the same thing as the square root of negative 1 times the square root of 36. Okay, again, I equals the square root of negative 1. Do not forget that. So when we come here, this is x equals, we have an I in front here. Okay, square root of 36 is 6. Okay, now when we go to simplify, like I showed you earlier, you would write this as 6i. And every time you take a square root of something, you want to consider both the positive and negative solutions. So what we have is we have x equals negative 6i or x equals positive 6i. So these right here would represent our two imaginary solutions to this particular example. Okay, let's go ahead and try something else. Okay, so same idea. Let's say we were to solve for x, given something like this. X squared minus 10 equals negative 17. Okay, so what I see here is we can add 10 to both sides. So we add 10 to both sides here, we get x squared equals, so it's negative 17 plus 10 is going to be a negative 7. So next what I see what we can do is we want to get rid of this square here. So in order to get rid of the square, we take a square root. So when we take square root cancel with the square, we get x equals the square root of negative 7. Like I told you earlier, you can break this up. So x equals the square root of negative 1 times the square root of 7. Next what I see we can do is, this is I equals the square root of negative 1. So this is I. So we have I times the square root of 7. 7 just breaks down into 1 and 7. This is already in simplest radical form, so we cannot break that down any further. Okay, so what that means is, like I told you, every time we take a square root of something, we want to consider both the positive and negative solutions. So we have something like this: x equals plus or minus I times the square root of 7. Okay, so what we have is we have x equals negative I times the square root of 7, or we get x equals I times the square root of 7. So these are two imaginary solutions that come out of this. In other words, like I told you earlier, it's the same thing as having no real solutions. Okay, I'm going to stop the video here and I'm going to continue really soon. Okay, bye. Alright, okay, so let's have a little bit more fun with some problems. Okay, so let's give you something like this. So x squared plus 5 equals negative 15. Okay, so what we can do is want to get x squared by itself. So in order to do that, we can subtract 5 on both sides. This cancels, so we get x squared equals, so negative 15 minus 5 is going to be negative 20. Next, what we want to do is we want to get rid of the square. So in order to get rid of the square, we're going to take a square root. So square root cancels with the square, get x equals, so we have the square root of negative 20. This is the same thing as x equals the square root of negative 1 times the square root of 20. Okay, so again, what I showed you in the last video, so x equals I, and then what we have is multiplied by the square root of 20. Now you might think to stop here, but actually 20 can break down. 20 can break down into 4 and 5. 4 can break down into 2 and 2. So we have the square root of 20 equals the square root of 2 times 2 times 5. Okay, so what I see here is we have our partners in crime. One gets shot, one comes out. 2 times the square root of 5. So square root of 20 is the same thing as 2 times the square root of 5. So this gets replaced right here. So x equals I times 2 times the square root of 5. Like I told you earlier, you can, this little thing here, you can actually rewrite it. So something like 2I times the square root of 5. And another thing that I also mentioned earlier, anytime you take the square root of something, you want to consider both the positive and negative solutions. So what this means is x can equal negative 2I times the square root of 5, or we have x equals positive 2I times the square root of 5. So these are two imaginary solutions that come out of this. Okay? Alright, so let's do another example. Alright, so same idea. All we're doing is solving for x. 6x squared minus 5 equals negative 8. Alright, so some of these problems are going to get kind of interesting. Okay, so let's say we add 5 to both sides. Add 5 to both sides here. So we get 6x squared equals negative 8 plus 5 is going to be negative 3. We have a 6 over here, so we're going to divide by 6. 6 cancels. You get x squared. If you reduce negative 3 over 6, this is 1 halves, right? So what we have is this is x squared equals negative 1 over 2. Okay, what I see is we have a square here. So what we can do is we're going to take the square root both sides. Square cancel with the square root cancel with the square. So we get x equals. So let's just skip a little step here. This is the same thing as square root of negative 1 times the square root of 1 half. Alright, so square root of negative 1 is going to be I. And then we have the square root of 1 over 2. So if you guys remember how to do something like this, what we have is the square root of 1 over 2 is the same thing as the square root of 1 divided by the square root of 2. Okay, now what you could do from this is, well, square root of 1 I see is 1. So we have 1 divided by square root of 2. So that's essentially what this becomes. So x equals I times 1 divided by square root of 2. But like I told you, like I mentioned other assignment, we don't want square roots in the denominator. We want to get rid of any square roots in the denominator. So one way we can do that is we can rationalize the denominator. So what we can do is we can multiply top and bottom by square root of 2. So what we have here is if we multiply together, 1 times square root of 2 is just square root of 2. And when we come down here, so square root of 2 times square root of 2, if you guys remember, that is basically the square root of 2 squared. The square root would cancel with the square, or in other words, you can think of it as the square root of 4, and the square root of 4 is 2. So this expression here is the same as this, so we're going to replace it right there. Okay, so running out of room here, so this is basically x equals I times the square root of 2 divided by 2. Alright, so now what we can do is we can actually put this we can put this I in front here. That's generally how it's written. Yeah, you just put the I in front. So this would be square root of 2 divided by 2 I. And every time you take a square root of something, like I mentioned earlier, is you want to consider both the positive and negative solutions. So what this means is you get x equals, so negative square root 2 over 2I, or we get x equals positive square root 2 divided by 2I. So these are our two imaginary solutions that come out of this. Alright, one more example, something similar. Okay, 3x 3x squared minus 4 equals negative 8. Okay, so what I see is we want to add 4 to both sides. So if we add 4 to both sides right here, 3x squared equals negative 4. We have a 3. We have a 3 right here. So we're going to divide by 3. 3's cancel, so we have x squared equals negative 4 over 3. Next, what I see is we have a square. So in order to get rid of that square, we're going to take the square root. Square root cancel with the square. So we get x equals, again, I'm just going to do a little shortcut here, square root of negative 1 times the square root of 4/3. Now, what I have here is square root of negative 1 is going to be I. So I times the square root of 4 over 3. Now let's do a little bit of work here. So square root of 4 divided by 3 is the same thing as the square root of 4 divided by the square root of 3. Alright, if you guys see, square root of 4 is a perfect square root, so square root of 4 is 2. So this is the same thing as 2 divided by the square root of 3. So if you were to put all these little steps here, so you could put I as the same thing as I times 2 divided by square root 3. Okay, next what we need to do is we don't want square roots in the denominator. Nothing here. So what we want to do is we want to get rid of that square in the denominator. We want to rationalize the denominator. So what we're going to do is we're going to multiply top and bottom by square root of 3. Alright, so what we have is 2 times square root of 3. That comes right on top. And the bottom becomes square root of 3 times square root of 3. So, as you can see here, square root cancels with the square, and you just get 3. Or, if you want to, just multiply across, square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. Okay, so this expression here is what gets placed here. So I'm just going to go ahead and write it on the side here. So we get x equals 1 times, and we have 2 times the square root of 3 divided by 3. Just like the other example, it's just good practice, just put the I in front here. Okay, so we get something like x equals, so 2 times the square root of 3 over 3i. Alright, so what that means is if we were to write our final result, again, anytime you take the square root of something, you want to consider both the positive and negative solutions. So we have x equals negative 2 square root 3 divided by 3i, or we get x equals positive 2 times square root of 3 divided by 3i. So that is basically how you would do something like that. Alright, okay, so please let me know if you have any questions on anything. Okay.